Chapter 6, Surface Response. All right, so let's delve into a couple more things with surfaces and how light responds in relation to the way it reflects off of surfaces. So we've already covered a lot of the basics of light reflecting off of smooth surfaces, gives kind of a specular reflection. Light reflecting off of kind of rough surfaces gives a diffuse reflection. Let's look at some 3D examples and kind of blow through these really quickly and actually show you some of these things. So this is a 3D render with kind of an ugly front light, kind of like a flash cube. All right, so this is just diffuse reflection. Now the light can actually, emit diffuse and specular rays, but the surface really tells, how smooth it is and how the light is reflecting. As we, kind of noticed in this example, all the light's coming in the same way, bouncing dependent on the surface. All right, so this is with a little bit of specular in here, so we're seeing a little bit of specular reflection. Specular reflection can be changed. This is playing with some of the settings of the shader here to kind of tighten up or widen specular highlights or the intensity of it or the color of it. When you get into 3D rendering or 3D lighting, there's tons of different controls. I'm not going to go into those because this isn't about doing 3D rendering. You can learn that in some of the other DVDs, but just understanding the way light works. All right, so the goal of lighting an object is for you to understand its shape the best that you can. So there's a couple different kinds of lights. I personally don't prefer to kind of light something from the front like this. It looks really kind of ugly. So basic lighting, 3-point lighting, if you were to ever study that, you would see kind of this 3/4 lighting. So instead of coming straight from the front, it's coming from like a 3/4 angle. So you can kind of feel the fall off of the shapes. You want to get a sense of this kind of modeling, the shape and the form of everything. All right, so we got this big dark area. So there's a couple things we can do about that. You could leave it, and maybe stylistically you want that. There's other forms of lights that we could use. We could use what they call a kick light, which is just kind of a low-level fill in the area opposite, kind of 90 degrees opposite of the key. So it's coming in from kind of from this direction. We have bounce lights here that let me put this just by itself. All right, so this is a very soft. Notice on these kind of lights I'm putting a very soft shadow versus the key that has a very harsh shadow. So because it's a diffused bounced light, I'm saying that it's bouncing off of diffused surfaces, so I give this light a very, very soft shadow. There's rim lights, just kind of add a little bit of shaping again to kind of see the shape and the form of light kind of rimming on the edge here. You can have another kind of rim. You can have both rims together. You could have the key, a kick light, some rim lights, add everything kind of all together here. There's another way, instead of doing a kick, sometimes I like to do like a soft fill, like we had talked about, kind of the sky dome. Instead of a light that's just coming from one direction, want to get that effect of the blue of the sky, or if it's a cloudy day, just kind of the gray of the sky. So this is a cheat here for 3D rendering of making one light kind of coming front here, having really soft shadows, duplicating that light and kind of rotating them all around. So this is multiple lights hitting this surface, all with very soft shadows. So instead of using a kick light, I might use this kind of soft fill light and get something where you have all the lights together. Now this is putting a little bit of color in here. So we have key light with a nice harsh shadow. We've got the soft fill light that I've made kind of cool. We got a little bit of those rims in here, and we've got a bounce light that I've actually added some warmth to it to kind of mimic the light off the ground like we've studied in some of the bounce lights in the earlier chapters. All right, so you get a pretty good feel. This is kind of basic lighting A lot of rules to be broken here because it's not an exact science. It depends on the look you want to give it, but these are kind of the standard rig lights for a character, kind of key, fill, bounce, kick, rim, basic lights there. Okay, so we understand quite a bit of what happens with light and the basics of light. Let's quickly cover refraction. So refraction, again, is when light comes in through a surface, a transparent surface, and then is bent. So what we're seeing here, we're seeing light that's coming in, it's kind of reflecting, and when it's reflecting back to our eyes, it's refracting inside of this plastic. So that's why we're seeing this kind of warping of what we would normally see inside. Same with headlights. The glass, the reflection in your transparent area here, when the glass bends, the light is bent. When it comes to our eyes, we actually see this kind of warping. So if you're kind of painting in or creating a 3D scene, understanding refraction, it's a pretty basic thing, but it can give some nice complex looking images. Understanding that refraction happens. Alright, so there's also a thing called caustics, where the light, it's not only what's coming to our eyes that's kind of distorted here, but these bright spots like a magnifying glass. When you get that nice hot spot on the ground, the light is actually being bent and coming all to one point, forming a hotter spot and darker spots. So here's caustics from this water bottle. You get all this kind of complex, not just the light that's coming through is being bent and kind of giving these hot spots. Now, an interesting thing as we go on to something a little bit more complex is to look at the this glass here. It's actually giving us caustic glow too, but it's diffused. So there's refraction, you know, that's very clean to understand. It's like a specular reflection is nice and crisp and clean, and then you have a diffuse reflection that's far more complex. Same with refraction. You know, you've got this nice clean refraction that has very sharp caustic lights. Then you have this very soft diffused refraction, and it gives a soft effect. Let's talk about this more in detail. Okay, so subsurface scattering. So translucence here, or subsurface scattering. So if we have light that's coming in into a transparent object like glass, we might get the light might be bent slightly as it comes out, kind of like we saw in that headlight. Then if we have light coming into off of an opaque surface, we're just going to get reflection where the light's going to bounce off, and it can be diffused or it can be, specular reflection. But what if we have translucent or semi-opaque, somewhere in between these two? So we're going to have the light that comes in, and it gets a little more complex here because there's light that reflects off of the surface. So some of it reflects off and some of it kind of passes through, but because of the little tiny details of the material, it's bouncing off of multiple, or kind of the internal surface here, and scattering out. So like that image we had with the refraction here, the light's coming in, it's kind of scattering around inside the cup and then exiting out. So you get this kind of blue glow here of the light that's coming through. We're actually seeing the shadow of some of the stuff that's up here out of the window too. So you can kind of see through an object like that. So that's translucence. Now if you have something thin like something like leaves, you can kind of see the light. Turn this off here. You can see the sunlight coming through, and you can see these kind of areas where the light is allowed to pass through, the thinnest areas, and this kind of glow. You see a leaf. See, I have an image here. A leaf with the sunlight. This area here is translucence. So understanding how the light kind of comes through, and we can see the shadows. Now there's something besides translucence. There's subsurface scattering. So let me talk about that. So if we have something thick like skin, but it has enough translucency to let the light kind of come in here and kind of scatter all around. So it gets diffused as it goes in, but it's not necessarily going all the way through. We get some light that's reflecting off the surface, some light that's kind of coming in, and then there's some light that actually kind of bounces back up and comes out at multiple different angles. So instead of getting just a reflection or refraction, we're actually getting kind of this glow as the light reflects off of, you know, all these different surfaces on the inside. We call this subsurface scattering, or I call it that. Kind of common in computer graphics too. So let's look at some examples of subsurface scattering. All right, so the light is coming in, it's hitting the back of the ear, and then going through the ear, you see all the red of the blood and everything on the inside. It's kind of gross when you think about it. But the light is scattering throughout all of the skin and the flesh and the cartilage and the muscle and everything, in the kind of scattering out. What hits our eyes is this very diffused light from this complex refraction. This is another good example of light. Some of it's hitting our eyes, so we can see, you know, we can see the shape of the outside of this, but a lot of this is kind of hitting inside this orange, scattering all over the place and giving this nice kind of glow. Of course, closer to the area where the light came in, you're going to get a brighter area. Notice the color here, just like the last chapter. You got this kind of yellows to orange to kind of reds down in here. So it's interesting to study here is it's not just the orange. Look at his fingers too. So the light, you get the reflection off of the skin. You get this kind of area down in here where, you know, the light is shadowed. But you got this kind of warm kind of glow. That's the subsurface scattering of his skin, of the light going through his skin, reflecting off of the blood and the bones and the muscles and everything in there, and then exiting out again through his skin because the light is so bright that we're getting this subsurface scattering. Common thing with computer graphics is that a lot of people don't think about that, and they're like, why does my character's skin look like plastic? Why can't it look like skin? It's a hard thing to get it just right. Subsurface scattering is one of the things that kind of makes this believable. Something as simple as like a towel hanging outside, the light comes through it, we get this kind of soft glow here of the light that's kind of hitting underneath here, behind here. Kind of see the translucency there. This has a lot of subsurface scattering. As the light comes through the plastic, a lot of light is kind of diffused into here, and you almost have this kind of glow to it. It's a good thing to observe and to think about when you're creating your artwork. Again, you got this bird, so if I were to be painting an image of him, or creating this in 3D, I have my key light, I have my bounce lights from the hottest area. Look at all that nice bounce light that's kind of coming up here and onto his face. But look at this nice red line here. That's the subsurface scattering of the light coming into his beak and kind of bouncing around. Even in the fur itself, we're getting this translucency, this light here. This is, some of this is bounce from his beak, and some of this is subsurface scattering of the light, kind of the translucency of the feathers and light scattering around inside the feathers and giving this nice warm glow. This is another reason why colors tend to saturate in the dark areas. You got the subsurface scattering that also increases that effect. That's why you get so much of this yellow and warm color in here, because the light's kind of scattering around. Practical examples of this, we could have, and this is really quickly painted just for this demo, you know, to say, all right, we've got this light coming in. Well, what if we wanted some subsurface scattering in here? You may or may not, but you want to get that effect that this light is really hot, kind of coming through his ears here. Practical example. All right, let's talk about one more thing concerning surfaces, and then we'll go on to the next chapter. All right, so I tend to call this facing ratio effects. So besides subsurface scattering, besides basic reflection and specular highlights, there's something else that I observe in the real world where certain objects will give you a different type of light response based on the angle. So something like, something soft and fuzzy, opalescence. You get things that are, I don't even remember another term besides opalescence, but that kind of pearly type thing. And Fresnel effects. Let me talk about what those are. Let's start with the basic stuff of kind of soft fuzzy things, the most easy to understand. Okay, this is something I observe in the real world is what makes this look fuzzy. I think it's actually this kind of soft, as our eye, if I'm looking directly at this, I'm seeing very little fuzz, but as it gets to a greater angle from my eye, from a 90 degree to, as it gets to a greater degree here, I'm actually seeing through a lot more of this surface fuzz. So it kind of accumulates based on angle because I'm seeing a lot more of the fuzz, and you get this kind of soft hazing edge. So we can mimic this in 3D or in 2D if you want to paint it on. So this is kind of a basic shader on him, and then I'm doing something using a facing ratio effect to add a little bit of softness. So I'm telling the computer, this is in Maya using a general utility node, to say, give me a little bit more light, give me a difference based on the angle. So right here I'm getting, this kind of flat orange, and as it gets to the edge I want to get it a little bit lighter. So you can see the difference between these. It's subtle, but it gives that kind of effect like his skin is just ever so slightly soft, that little peach fuzz of skin. You can do this with shaders. Kind of thinking about the real world and what happens in the real world and building your models, your 3D geometry, your shading, your paintings based off of what happens in the real world. All right, so there's things kind of opalescence. This bug is kind of cool. I probably should have videotaped this. Kind of if you move it at different angles, you get this kind of different kind of fall off. It's almost holographic, like a CD. Depending on the angle from our eye, because of what's happening under the surface here, you can use the same kind of facing ratio effects. Jellyfish do that kind of same type of thing, kind of soft on the edges as the light kind of accumulates through this kind of gelatinous surface, but we get that kind of facing ratio effect where things will have, it almost looks like it's rim lit at all times because the way the light kind of accumulates through the surface when you get a tight angle. Now there's something else that's called Fresnel that is quite common, though very subtle. Don't overuse this. So like water surfaces and cars and most reflections actually vary based on the angle to your eye. So at a very harsh angle, way back here, it's almost all reflection. You get this area where I need to draw this because this will just make more sense if I draw this. Alright, so, oh boy, I need a smaller brush. Alright, so if I have water surface, my eye is right here. Light that, if I'm looking down here, the light at kind of this angle will reflect differently than light coming in from this angle. And I'll actually get a stronger reflection, kind of index of reflection here. They call it Fresnel. So let's forget about the technical details of this and actually talk about practical. Notice that the sky is white. It was a kind of a cloud, sunny day, and the kind of bright morning, light blue kind of sky. Over here you're seeing the reflection of the sky, and then as it gets to a less of an angle here, it gets really dark, and actually we're seeing through the water down into, we're seeing the bottom. So there's less reflection of the sky here than there is right here because of this Fresnel effect, because of the angle to the water. Let me give you another example. All right, so these windows I'm at a harsher angle from, so they actually look brighter. So I'm seeing more reflection because I'm at a harsher of an angle than I am here. I'm still seeing a reflection, but the reflection is darker here than it is here. So proof that something's happening there is if I move just a few degrees, kind of walk around, now this window is brighter and this one is less reflective. It's kind of that Fresnel effect. So subtle thing that happens, you want to take this very lightly when dealing with computer graphics, but I figured I'd talk about all of these different little things that happen with light. So certain responses of light. So there's a lot that can happen here with light. Here's a quick example to close out this chapter of something I painted, put in a little bit of bounce light, kind of painted in this subsurface scattering. So getting this kind of little bit of red glow where the light is the brightest. You can see it the best in his nose. To give that idea of light is coming in and doing something far more complex, even though the lighting setup in this painting is pretty simple. All right, so take some time, study what you see in the real world. If something is made of skin, if something is made of wood, something made of metal, something made of cloth, something like gelatinous surfaces, and study what the light does, and kind of focus that in when you're creating your artwork. All right, let's talk about a few more things in the next chapter.